So yes, R squared is a good end-all, be-all, overall measure of fit. The problem with R squared is that it always goes up whenever you add a variable. So it kind of gives you a false belief. So R squared's formula is 1 minus the SSE divided by the SS total. The denominator is the sum of the yi's minus their means squared. So this term here, SS total, never changes. You can think of it as being fixed for a given data set, okay? The SSE depends on the model. Depends on the number of X, the number in which X variables are in the model. But suffice it to say that each time a variable is added, SSE decreases. So that's kind of the key condition. So every time I add a variable, if SSE decreases, this is fixed, this thing gets, this thing gets smaller, R squared gets bigger.
But even if you had an X that has absolutely no exponent.
Yeah, so that's right. So if it had absolutely none, it would stay the same. Okay, so you're right, there isn't, right? Unlikely that that's gonna happen, right? Because it'll have some exponent, but very, very small. So we'll say decreases or stays the same. Yeah, you got me there. That's true in theory, it's just really not true in practice. So therefore we have this measure adjusted R squared. So what adjusted R squared does is, adjusted R squared, I'm not gonna know the formula off the top of my head, but I'll say this about it. It, like R squared, increases when meaningful variables are added. But when variables with little to contribute are entered, there's a small, R squared declines, adjusted R squared declines.
Why would it decline and not stay the same?
It has, okay, so that's a good question. It has a term in there. Let me show you the formula on adjusted R squared. And you'll see why I didn't want to show you the formula. It has a term in there that penalizes. Okay, so let's see if can I make this bigger? Let's see. Yeah. Right. So this is one formula from R squared. I really don't like these formulas because it's got like 1 minus 1 minus in there, right? What does that mean, right? 1 minus R squared. So it's a function of R squared, right? But what happens is, so if R squared goes up, so does adjusted R squared, right? Except the P is the number of variables you put in there, Jacob. So if P goes up by 1, and minus P gets smaller by 1, this whole thing therefore gets larger, but there's a minus sign in front of it. Okay? That probably was clear as nothing, right? Let me say that again, right? Every time I add a variable, P goes up by 1, that's the number of predictors. So this thing gets smaller because P gets bigger. Therefore, this thing gets bigger because this thing gets smaller, but there's a minus sign in front of it, right? So the whole thing goes down. So on one hand, this thing is causing this to go down. On the other hand, minus a minus r squared is causing it to go up. So, and it turns out that there's lots of measures like adjusted r squared. Adjusted r squared is only one such measure. There's lots of other examples of measures like adjusted r squared that try to get at the trade-off between being expedient on one hand and explanatory power on the other. So the graph for adjusted r squared for a given situation. And again, if we can get r to work, I'm back to not being optimistic, right? If you graph the number of predictors versus adjusted r squared, right? When you add the first one, the best predictor, it goes way up. The next best predictor, the next best predictor, the next best predictor. What starts to happen with adjusted r squared is it starts to go down. So you say, well, I'm going to pick the model that sort of where adjusted r squared was maximized, somewhere around here, right? So it doesn't tell you the best model necessarily, but it's a heuristic that says, you know what, adding variables 5 and 6 here didn't really contribute much, so there was no reason to add them, okay? So adjusted r squared is kind of a useful heuristic. There's better ones. But adjusted r squared that's the goal of it. So if, for example, on the two models that we fit here with Glencove, right, if you look at the 6 variable model, the adjusted r squared is 0.807 in the 6 variable model. And if you look at the 3 variable model, the adjusted r squared is 0.810. So notice that it's actually higher adjusted r squared with 3 variables than it is with 6. That tells you those last 3 you added didn't really contribute much, right? So it's another piece of evidence. It's not a statistical test, but it's another piece of evidence that maybe 3 is just as good as 6. All right, so you know, we can go back over the interpretations if you want. I mean, yeah, question.
You said it increases when meaningful variables are added, and what's the categorization for meaningful? Is it p-value?
Remember, we started with everything in there, right? And when you have everything in there, unless you're going to add some other variables or some other functions of these variables, your r squared is as high as it's ever going to get. So it's 85. That's where we started. Then what we did is we noticed that 3 of them don't have significant p-values. So we took those 3 out. We wound up with this. We wondered if this r squared decrease from 85 to 83 was big or meaningful. So one way we can decide that question, Jacob, is to look at adjusted r squared. Okay? So I can't tell you how much increase in adjusted r squared is meaningful, but what I can tell you is if adjusted r squared is going down when you're adding variables, they're not contributing very much.
But how does it decide?
Again, it's that formula I just showed you, right? It's in this formula,
okay.
right? It's in this formula. See, remember, every time I add a variable, r squared is going up, right? R squared is going up. So adjusted r squared, because it's minus a minus, is also going up, right? The capital N is not changing because that's the number of rows, all right? But every time I add a variable, P is also going up. So by the fact that P is going up, this thing on the bottom is going down, this whole thing's going up, but minus it's going down. So the P is causing it to go down, the r squared is causing it to go up. So it's a battle between the two of them, right? At the beginning, when you add really meaningful variables, the r squared is winning. But later on, when the r squared isn't changing by very much each time you add a variable, the P starts to win.
Is it fair to say R square adjusted factors and the number of predictors and sees
Right.
what percentage of change happened, and then it assesses.
Yeah, I wouldn't say the second sentence, but I would say that's right. Adjusted R squared takes into account the complexity of the model, where R squared doesn't bother with that. So that's a good, well, the first thing you said is really good. Yes, Rob?
So if R squared increases and adjusted R squared decreases, by adding the variables, then which one has more leverage? And is it 1% of R squared equivalent to 1% of adjusted?
No, not exactly. So this graph, so if this black line were adjusted R squared might look like this. And then start increasing very slowly, right at the end. So R squared, you keep adding variables, it'll never decrease, right? It'll level off. Obviously, it'll never get up past 1, right? It can't go past 1, right? But adjusted R squared will always be a little higher. And you can't interpret adjusted R squared the same way as R squared either. So R squared's the one with the nice interpretation. But adjusted R squared is the tool you use to sort of decide how complex the model, and after that, okay? So that's the only thing I know about it. I really shy away from interpreting adjusted R squared because its formula is, it doesn't make it easy to interpret. I tried to rewrite it for a lecture and simplify that formula some algebraic way, but it doesn't really work. All right, any more questions on Glencove before we move on? Basically, we learned that land, an acre of land is actually a really big, I don't know, another ridiculous British measure, but an acre of land is a big space of land. In fact, let's just look, how big is an acre in square meters? That'll probably help.
I think it's 4,000.
Yeah, it's not some round number like 10,000. You might have a metric acre or something, but how big is an acre in squared meters? There we go, down here. Yeah, roughly, Michael B was right, about 4,050. So that's a big old, you own an acre. If your house is on an acre, you're probably a farmer or something, right? Because, or you have a horse or something, right? You might need several acres for a horse.
That's 10,000.
Yeah, a hectare, that's something different, right?